Today's episode is about why AI agents are impossible to govern like normal code. So, here is a problem you can fix with a better prompt. You write an LLM agent, run it on a task, it works, there is no problem there. Then you run the exact same task again. Same code, same prompt, same model, and it does something different. Not different wording in the answer, sequence of actions. It calls the tool twice when it should have called it once. It loops. So, same input, different behavior. That breaks the one assumption all your testing and code review rests on, that the code determines what the program does. For an agent, it's different. It doesn't. So, you have to treat the agent as a non-deterministic worker. You hand it a job, and you don't get to specify the steps. The model picks them at runtime, one decision at a time. A regular function maps input to output. This maps one input to a distribution over action sequences. Same question, many possible runs. So when you read the source code, you're reading what the agent is allowed to do. Its space of possible moves. You are not reading what it did. Those are two different things, and the gap between them is the entire subject of this series. We will be using one agent for the whole series. Let's call it the research then answer agent. The job is simple. Take a question, call a search tool to gather information, then write an answer. 3 steps in the intended design. Question, search, answer, and that's the code. We're going to run it twice on the same question and watch what actually happens. Let's first of all look at the clean run. You have the question going in, the agent calls the search tool once, it gets the results, it writes the answer. These are 3 steps. So you have the trace, you have the timestamp record of what the agent actually did at runtime. If you read it top to bottom, you have the step, tool, timestamp. So this is what you'd hope your run would be every time. So let's look at the divergent run. Let's call this run B. So you have same question, same code, same prompt. You have the agent that's calling search, it calls it first time, then a second time that's redundant, then third time. 2 redundant times. So in the end, you get an answer. But you did 5 steps instead of 3. In your repository between these 2 runs, the model just made difference at runtime. Your repository didn't really change. This is not really wrong. So run B might yet return the same answer, but it still has a wrong behavior. It's a redundant loop you can't see anywhere in the code. Because it isn't in the code, it only exists in the trace. So if you look here, the divergence is at the orchestration level. The order and number of actions the agent takes is not dependent on how smart the model is or clean your wording was. So just write a better prompt is the wrong lesson. A better prompt lowers the odds of a bad path. It doesn't make the behavior deterministic. The non-determinism is structural, built into how the worker operates. The general lesson that you have to learn from here is that you're gonna govern the trace, not the code. As we can see, if you change the code or the prompt, you're not really having any insight on the level of orchestration of your agent. So you need to actually orchestrate the actions taken by that agent. So here is where this goes. If behavior lives in traces, governing an agent is 2 jobs. 1, capture valid traces. That means turning what the agent did into a clean event log you can analyze. Second is check whether what happened matched what was supposed to happen. That second job has a name. It's coming from process mining and it's called conformance checking. Over the next episodes, we will be building that governance layer in code with a library called PM4Py, using the same agent as it grows into multi-agent system. Our next episode will be observability isn't governance.